3D crosspoint tech gain in IOPS, huge, and a 12x NAND solid-state drives. But the breakthrough of 3D crosspoint technology really comes with its use as system memory. So it will displace traditional DRAM. 3D crosspoint memory solution delivers twice the capacity of DRAM at far lower cost and at the same performance. It's a breakthrough for server apps that have large data sets and demand that high-speed execution. The perfect example, of course, being data analytics, an area of exclusive opportunity for IT to inform the business. So today's two-socket Xeon server supports up to 1.5 terabytes of DRAM. With the launch of 3D crosspoint next year, we'll support up to 3 terabytes of memory at 30 to 50% lower cost. And Oracle will be obviously an early adopter of our 3D crosspoint memory DIMMs as well. Over the past 7 years, bandwidth into the server has increased by 50x, going from 1 gig in 2009 to now 50 gig today. So traffic growth across the data center is creating a true network bottleneck. Today, that traffic across the data center is handled by traditional fiber optics. Optics is obviously required due to the reach and bandwidth, but fiber optics is expensive. Over 50% of the total network spend is on optics, and that percent is growing. So there is a clear need for a breakthrough in high-speed network interconnect. And so last month, after 16 years of development, starting in Intel's labs, we launched Intel Silicon Photonics. And Intel brings a clear advantage in optical interconnect. It is the only solution that builds the laser on the silicon. So we integrate the laser light emitting material, so indium phosphide, with silicon. And then we use the silicon lithography process to actually define the laser, to align the laser with precision. This delivers to IT a cost advantage, a performance advantage, which translates to longer reach, and a density advantage. So the first Intel Silicon Photonics is 100 gigabits per second, and it's targeted at the connection across the rows and across the data center. As the server network bandwidth increases from 10 gig to 25 gig and then to 50 gig, optics will actually also be required direct to the server. The existing electrical connections inside the rack will hit a brick wall when we get to 100 gig serial speeds. So we see a future where optical I/O is everywhere in the data center, and our ability to run optics on the silicon gives the IT world compelling and unique benefits, and we are shipping silicon photonics in production today. Earlier this year, we launched the next generation Xeon processor, the E5v4, and that's based on the Broadwell microarchitecture and 14 nanometer process technology. It delivers 22 cores, increased memory bandwidth, and impressive virtualization technology that again delivers a more efficient cloud solution. A huge benefit of the Xeon E5 product line is the fact that it delivers high performance across the full range of workloads. We're delivering up to 44% performance improvement over the prior generation of Xeon at the same power across compute, storage, and network workloads. Intel Xeon is the foundation of cloud computing. The cloud runs on Intel, and through our work with partners like Oracle and other leading enterprises, we've developed a deep understanding of the challenges that IT faces when trying to deploy a cloud that is both high-performing and highly efficient. So we've taken all that insight and we've driven features down into the silicon. With Xeon E5v4, we added a new feature called Intel Resource Director Technology, or RDT as we say, to solve the noisy neighbor problem. So if you don't know what the noisy neighbor problem is, I'm going to tell you. Intel RTD is a set of silicon features that directs the cloud orchestrator. So it ensures that the application has all the resources that it needs in order to meet the SLA that has been committed by IT. And it does this by monitoring, controlling, and reporting cache and memory usage. So I'll show you how it works using the on-die cache resource as the example. So in this example, before Intel RDT, the server's cache resources are allocated to the application that comes in first. So first serve. Allocation is independent of what the application's SLA might be and what the performance requirements of that application might be. So this allows the creation of the noisy neighbor. With RDT deployed, the cloud orchestration solution has the ability to bound the cache resource and create priority amongst the virtualized applications. So a high priority app, the green app in this case, has priority access to the cache and can deliver the performance and the SLA that IT is committed to the line of business. When your high priority app is sitting idle, the lower priority app, orange in this case, can then expand its access to the resources and run at higher performance. When no one else is home, the neighbor can be as noisy as it wants. But when the needs of the high priority app then increase, the RDT feature will automatically evict the lower priority app from the cache. So this is a nice little cartoon, but it is incredibly valuable in increasing the utilization of your infrastructure while meeting the performance commitments. You no longer have to over-provision your infrastructure, as we all do, in order to meet the SLAs. It is also a key and critical feature to support the move of your network from fixed function appliances onto network function virtualization. So RDT will ensure that you're able to maintain your packet processing quality of requirements while also deploying new features and services like intrusion detection and prevention. Oracle consistently leads in the adoption of next generation technology to continue that commitment of delivering the very best optimized solutions for enterprise. And the wonderful thing about Oracle is they provide choice. They provide their customers with both a premium performance experience on-premise and a premium experience through the Oracle Cloud. And last year, we jointly announced Project Apollo. And this was an Oracle Intel joint engineering program to optimize Oracle Cloud using Intel technology. Thomas Kurian, Oracle's President of Product Development, planned to be here with me tonight on stage, but unfortunately is aiding a family member with a medical situation, and I'm very grateful to him, though, for being able to make this video and share his thoughts with you on our partnership and the team's progress. So let's see the video.
Thank you, Diane. Happy to be here to share our progress. I'm sorry I can't be with all of you in person. Last year, we announced Project Apollo, a joint program and lab that enables Intel and Oracle experts to work together to optimize real cloud workloads in a scale-out data center environment. We started by optimizing performance and variability for Java as a service, and we were very encouraged by the results. This year, we expanded our collaboration to workloads beyond Java to include database as a service, big data as a service, and software as a service for our applications. And we've seen fantastic results. For example, in human capital management, software as a service, Intel and Oracle collaborated on software optimization for the new generation of Xeon processors, and we delivered an incremental 1.8 times performance improvement. This is a great example of Intel hardware and Oracle software working better together. In addition to performance optimizations, we've also collaborated closely to utilize Intel cloud technologies in our own data centers through the deployment of Intel Resource Director technology. Through experiments where we ran multiple workloads together in Oracle's cloud data center environments, we have shown that RDT delivers up to 52% better performance for throughput applications. In addition, we've seen a 4 times improvement in application response time and up to a 3 times reduction in variability of response time. We will continue implementing Intel RDT and other Intel cloud technologies in our own environment. And ultimately, we'll extend these technologies into our products so our shared customers can benefit from them as well. We look forward to a continued partnership between Oracle and Intel. Diane, thanks once again.
Yeah, there is I want to thank Thomas for sharing his thoughts. The results have been outstanding, and it is certainly a lot of fun to partner and collaborate with Oracle. So thanks for that. So thanks to the pervasive reach of cloud computing and the increased availability of connected devices, we have millions of terabytes of data that are now being generated every day. Whether you call it big data, data analytics, machine learning, artificial intelligence, this is the big buzz in our industry. So the question is, why now? I mean, heck, we've been talking about artificial intelligence since the 50s. So there's three big enablers to the why now. Number one, it starts with cloud computing. It is a fundamentally more efficient way to connect and deliver services. Number two, it's pervasive connectivity. Secure connectivity can be assumed, and it will continue to improve in the move to 5G. And number three, at the foundation is Moore's Law, cost efficiency of technology. Over the past decade, the cost of servers has declined 40% and the cost of storage has declined over 90%. It is now cost feasible to store and compute on massive, massive amounts of data. And all of this has then brought on a tremendous investment in the algorithm techniques space. Massive amounts of data enables tremendous opportunity. We are reaching the tipping point where data is the game changer. It is the differentiator for business. And while the phrase artificial intelligence often summons up visions of great science fiction, it isn't relegated to novels and movies any longer. Artificial intelligence is all around us, from the commonplace talk-to-text or photo tagging, fraud detection, to the cutting-edge precision medicine or injury prediction in sports or autonomous vehicles. Encompassing compute models from business intelligence to data analytics to natural language processing to machine learning, artificial intelligence is transforming the way businesses operate and how people engage with the world. And while enterprise IT may have been slow in the adoption of cloud computing, our collective goal should be to ensure that enterprise seizes the opportunity that artificial intelligence brings to the business. In fact, many large businesses are already benefiting from the insights of data and artificial intelligence. They are transforming. And a great example is UPS. So UPS saw analytics as a key differentiator opportunity in their journey for operational improvement. UPS delivers more than 20 million packages every day. And so rather than leave the route to the decision of the driver, they knew that if they could optimize the route, shaving just 1 mile per driver per day off the day's route, it would translate to a savings of $50 million a year, bottom line savings. So UPS created their integrated optimized navigation system, codenamed Orion. Orion uses expansive fleet telemetry and advanced analytics to gather data and calculate countless amounts of data to provide the UPS drivers with that optimized route. UPS was able to reduce 85 million miles last year, equating to over 8 million gallons of fuel and a reduction in carbon emissions of over 6,500 tons. So transportation, an industry founded centuries ago, transformed by data. For the wide range of artificial intelligence solutions, Intel is the optimal platform. I certainly believe that. There is a tremendous benefit in running on Intel architecture. A common and consistent programming platform and model is key, whether you're building or training your data model, whether you're scoring that model across real-time events, whether you're running a scale-up in-memory analytics solution, or whether you're running a scale-out Hadoop solution. You want to have a common development platform, and you want it to match the deployment environment. So for scale-up solutions, we provide leadership with Xeon E7 and Xeon Phi. For big data scale-out solutions, the platform is Xeon E5 with Hadoop. Machine learning and its subset technique, deep learning, which gets a lot of buzz lately, runs best on a combination of Intel Xeon Phi and Intel Xeon. It is the most widely deployed processor solution for both machine learning and deep learning. have to say machine learning and deep learning, by definition, it's a distributed, parallel, high performance workload. The math for deep learning is not complex. It's simply linear algebra. We all passed that hopefully back in Algebra 2 in high school. But what's new and what gets the buzz is the enormous scale. So the more data you can compute, the more accurate the model you'll get, and the more compute capacity that you have, the faster you're going to be able to train that model. So Intel architecture inherently scales. It scales